Consistencies. All right. So I'll move my face up there. Okay, now we're looking at this. Shh, silence. Okay. Now, why do I have this one separated here and to do live? Well, first of all, whenever you see this square thing, we do want to do the square rooting way of solving. It's a very fast, efficient way, but do not do it until it is isolated. And then I didn't realize I didn't say this last hour. Does 18 over 4 reduce? Yes or no? 18 over 4 reduce? It actually does, but don't. Okay, and I forgot to say why I didn't do this last hour. Because now what I'm going to do is square root both sides. And the reason I didn't reduce is this. What's the square root of 4? Simple. What's the square root of 4? So on the bottom, if I would have reduced, I would have made that 9 halves. And then I wouldn't have had a perfect square on the bottom. And one thing you got to remember now is why I'm going over this. How do I simplify a radical? Because now I have a radical answer. It's not perfect. So I do free this. Don't make this mistake. It is plus minus, right? Anytime. Why? I just went through it all. I'm sorry, not on the video, but it's just because both a positive and a negative squared equal the same thing. So you get a plus minus in any time you square root both sides. And then we proved that these two answers work on this previous one. So it's established. And then another thing, this is why I'm doing this one. How do I simplify a radical? One rule in radicals is I must not have a radical in the denominator. It's just like a silly math rule. Well, I took care of that. All right. Then up on the top, what's 18? A number. But what times what is 18? 9 times 2. What's the square root of 9? This always blows my mind, students that like can't handle this. Because I can take anyone off the streets and ask them what's the square root of 9, and they'd be able to tell me 3. Well, 18 is 9 times 2, and that's underneath the square root. I simply square root that 9 and get 3 free outside of that root. But the 2 is stuck, all right, because it's not a perfect square, so we leave it inside. I don't know why people don't get that. All right, and then the next thing you do is just subtract 1. Negative 1 plus or minus 3 root 2 all over 2. This would be a good answer. And I don't want to go over that fast, but what do you do when you try to subtract 1 from that plus minus thing? They don't interact. They can't be combined. So you just shove it like in front of the plus minus. All right, and then there is another possible answer. And I only do this because of potential multiple choice. What if you looked at the multiple choice and you did not see the circled answer? It's probably because they got a common denominator. This is grade school. This always makes me mad and gets me the shakes when a student says, "Where did you get that 2 over 2?" And I say, "Go back to 4th grade." I'm sorry, it's so mean, it's passive aggressive. All right, but it is true because that's all it is. And then what do I do next? I add the numerators. And put them over a common denominator. Again, this is not required of you to do this. What I'm worried about is if this was a multiple choice question, you don't see this answer, you can't panic. You have to say, "Oh, okay, I think they did a common denominator thing, and then that's why that's the answer." So both of these are correct. Just getting you prepared for every possible contingency. Big words there. All right, and now what if I run into here? Let's do this. I hope you didn't see that. Let's do this. Let's look at this now. Go ahead and write that down. We're still doing equations, but then we're going to move into inequalities. I didn't finish yesterday's thing with our. I really love the quizzes, by the way. It really reminded you of everything this week, and then we got into a new thing. But we got a problem, my friend. Son of a nutcracker. It didn't work. Okay. Oh, the paper moved. Let's see if I can. No, it didn't work. I'm so mad. Didn't that paper just move? I could have swore I saw that move. I don't know. Anyway, maybe I'm freaking out. You know how that drives me nuts, right? When the paper moves and I'm trying to write. I thought I solved it. But anyway, sorry that has to be on the video. Does anything multiply to -2 and add to 8? Any two numbers exist for that? So this is factorable or not factorable? Does anyone know what we have to do to solve this then if it's not factorable? Yes. Here, I'll tell you what it is. And you can play this all day long today. Because here it is. It exists on our calendar. And this is a great way to memorize. You ready? Square root of b squared minus 4ac over 2. I love the angry looks I'm getting. Only two more verses. You keep listening to this and book. Are you singing? Let's go. Nice. So no, no. You can play this all day long though. It's in the calendar. Okay, so when you don't have a factorable polynomial, you need to solve for it. You need to do the quadratic formula. So here we go. Wait, so let me get rid of that MA now because it means something else. Okay, fine. Now I'll show it. There it is. So and where does this come from? It comes from a concept called completing the square. Nobody cares anymore. Just accept that this is derived and turned into a formula that works to solve any polynomial, right? And we all should. Gosh, you math tours, you better have been shown this. Math two regular, definitely. If you had me last year, I would have played that song for you. So here we go. The opposite of b plus or minus the square root of b squared minus 4ac. I'm singing too fast. I'm too excited. By the way, this better be plus a negative 2, so c is negative 2 anytime you see a minus sign. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go. I couldn't remember that last part, so I had to sing it again. Okay, now, and this is why I have to go through this too, the ability to simplify with radicals and all that stuff. So here we go. Negative 8 plus or minus, still? All right. Square root 8 squared is 64. And then this is negative times negative, which is positive. So that's plus 8. All right. So the ability to deal with the math here and just not make mistakes, very important. I get people making negative mistakes all the time. One thing that kills me, and I don't have an example of it, when b is negative and then they put negative 8 squared but don't use parentheses, and then a robot types negative 8 squared on their calculator. You know what the calculator spits out when you just type negative 8 squared? Well, here, let's open up the calc because everyone's just looking at me like I'm some sort of freak, which they may be right. But negative 8 squared, enter, then a robot. Oh, let me write negative 64 in that little spot in the quadratic formula. For the love of dog, what's a negative times a negative? Positive. That is never negative in that position, no matter what. Okay, so now this is negative 8 plus or minus the square root of 72 over 2. And then what's 72? A number. But what times what is 72? Someone tell me something. 9 and 8. Okay, so I'm going to write this above. This is how I break down radicals. I don't do a whole tree. I think it's a mistake. And by the way, what's 4? Is there a perfect square? Sorry. What's 8? Is there a perfect square in 8? I just said it. So this is what I do. Okay, I know that's 4 and 2. I actually do this in my head, and then I stop. I have two perfect squares in 72. But let's make it easy. What's 9 times 4? What's 9 times 4? 36. I'll write this down. So this is negative 8 plus or minus. Well, sure. 72 is 36 times 2. You could probably come to that right away if you're really good with math. All right? Because what I want to identify is where is the perfect square in that number? What is the biggest perfect square? Then I can pull any bum off the streets and say, "Hey, what's the square root of 36?" What's the answer? That bum will tell me it's 6. Now, and again, so we're kind of covering some things that we're supposed to know, like backbones of math, so that we can function in the more complicated questions. Okay, then how do I simplify this? And kind of a lot of discussion in this last hour. Really, the best way to think about this is you can split this up into two separate fractions, the reverse of the common denominator. The whole thing of where common denominators come from. Because what happens, sadly, is a lot of people just cancel the 8 and the 2, and that's incorrect. That's all I can say. And then this ends up being -4 plus or minus 3 root 2. All right, remember this. I'm going to use this same example for our next set of notes, and you'll find out what that is. Okay, and then we got this one. All right, does anything multiply? Sorry, was that too fast? They're kind of too far away from each other. I'll take a break and take a drink. People are. It's a good idea. You know, my water, I put soluble fiber in there. You don't have enough fiber in your diet, everyone. So put 5 scoops of fiber in here, and zero taste. But that's why I'm shaking it. Huh? This one here? What? What? I just 72 is 9 times 8, and then 4. Crinkle, crinkle. It's my face. What do you mean? Oh, that's my body. Oh, you need this? Oh, okay. I was gonna move it. Okay. By the way, does anything multiply to 5 and add to 2? The opposite of b plus or minus the square root of b squared minus 4ac. I sing too fast. All over 2a. Okay. You'll see yourself singing it that'll be a way of memorizing it. That's the only reason I play that. Students every year say, "Gosh, that actually does help." As weird as it is. By the way, we should be able to do this fast too. 4 times 5 is 20. Oh no, what's 4 minus 20? Negative. Oh no, and this is another reason why I'm covering this. You got to be ready for this. Okay, I'll give you the short representation of this. Does the square root of -16 work? Is there a number times itself that could possibly equal a negative? No. So then a whole subset of numbers was created because of this. So what is it? What is the square root of -1? What do you guys know as it? What is it called? It's I. See, the reason they do that is so they can isolate it, get it out of there, so then I can evaluate the number as a positive, but still leave that little I there, saying that this came from a square root of a negative. It's just an idea, and you'll be amazed. The whole subset of I numbers created a whole new like math science. Without I numbers, you would not have the lights in this room right now. Electricity is derived. Electrical engineering needs I numbers. It's wild. It's mind blowing. And there's many other applications for I numbers. So you're at the cusp of the beginning of a big math concept. All you need to know is square root of a negative is an I number. So here's what I do. I isolate them. I isolate that square root of negative. So I write this as a product. This is true. -16, square root of -16. Separate square root of -1 and 16. What's the square root of 16? 4. And then what's the square root of -1 you just learned? I. So this is 4i. There's nothing to get or not. I don't get the I numbers. There's nothing to get. Okay? Whenever you see a square root of a negative, get that negative out of there and just make it an I number. I don't know what else to tell you. All right? And then this does simplify the same way. Guys, you can do this real quick. 2 goes into all of these. 2 over 2 is 1. And then 4 over 2 is 2. Now, I have a whole bunch of things to talk about what this means for a quadratic, but then we have to get into the next concept. And then here's the next concept. So you ready? Okay. Someone said no. Well, we'll still have to keep going. All right. Sorry. Time out. Oh no. Do I have two? Oh no. Okay, but I gotta make a copy. Copy. Control V because I have one more class. Okay, sorry. Okay, here's the next one. Here's what we're doing now. We're actually solving inequalities. Right? And then writing the answer in interval notation. So this is what we're moving into now. Now I want you to understand, I kind of on the calendar made this 1.5.0, and then this is 1.5.02 or so. I don't know what it, right before we have to remind you how to solve quadratics because we're in the quadratics chapter. So this is something that we have to practice. This isn't a quadratic. This is a linear thing. Fine. What I want to establish is how solving an inequality is different than solving an equation. So we have to do our simple task first, then what happens with a quadratic. By the way, we're going to write our answers in interval notation. So I'm leaving that up there so you can see the directions. And now we're going to zoom in just to this one. Okay, so numero uno, this is just a linear like solve. There's no x squareds. So the simplistic thing you would do is get, it is moving. Oh, that's because this is a new page. Okay, hold on. I know this shouldn't be part of the video, but I just got this from Mrs. Hughes. Nice. Wait, where was it? Set picture as background. Oh, okay. All right. Solve the issue. So subtract x and then subtract 4. This is different than solving a quadratic. A quadratic, you want to get everything on one side. That's negative 2x, sorry, equal to 0. But when you're dealing with a linear situation, you want x's on one side, numbers on the other, right? So it's a different path. Okay, I stopped and I froze here for a second. What happens with an inequality when I divide by a negative? You gotta remember this. Anyone remember? 3, 2, 1, go. Flips. The inequality flips from greater than to less than. So I just got to tell you, you got to remember that. There's a reason why it's simple, but just remember it. All right, and if you don't do it, you're going to get some wrong answers. Ooh. Okay. Uh-oh. Get this student over here coughing for 2 weeks, and now I got COVID. All right. So 3 halves. We're going to put it on a number line and understand where is x less than 3 halves, left or right? Left or right on the number line? So where's x at? Left or right on this number line? Where's that? Left. Numbers that are less than 3 halves are over here. Okay, and the reason I did that is so you understand how to write interval notation from this inequality. All right, and then, by the way, do you remember this? Is this an open dot or is it a closed dot when it's less than or equal to? Open or closed? Closed. We should remember that. You know, that's like a grade school graphing on a number line thing. Usually that's what they do in grade school. So how does this turn into interval notation? Well, what number is way over here? And the answer to that is negative infinity, right? And then all the way up to 3 halves. Crinkle, crinkle. Now, what do I put on 3 halves? What do I put on 3 halves? A bracket or a parenthesis? Which one is it? Bracket. Okay, and that's why I paused and, tried to get that. So solving an inequality is not just a number, or when we solve quadratics, 2 numbers. It's an infinite amount of solutions that solve the inequality, and it's got to be expressed as an inequality or an interval notation. You might as well get used to this, though. The AP is like 50-50. Like in multiple choice questions, I saw both formats, inequality or interval. You got to be ready for both. I really thought it was going to be all interval notation when we started this class, but no, they're half and half. Okay, so it's really the same directions. And no way, I am not doing number line analysis. We're going to do graph analysis. Way easier when we're dealing with quadratics. And this makes me so sad, students that can't figure this out. Because really it's based off of, we're going to say this till May, input, say it, output. If you understand a graph as a series of inputs and outputs, this is going to be the easiest thing in the world. So now, hey, look at your homework from yesterday that I'm not going to collect right now. Wasn't that number 1 from your homework? Did someone have it out ready to turn in and I'm just not taking it right now? Isn't that number 1, but it's an equal sign, right? Yep. So you approach the inequality the same way you did your homework yesterday. You just pretend it's an equation for a minute. And then what did you find yesterday? What multiplies a negative 20 and adds to negative 1? Or today, what are the 2 numbers? Negative 5 and 1. So we do our graphing. I'm having trouble speaking today. So a little upset about Kansas City. Wheat North. You guys know why. I didn't say it on the video, did I? All right. It's good. Now, we're going to say less than or equal to 0 right now. We could kind of treat that as an equation for a moment. And then we should understand that our key critical numbers are x equals 5, right? and x equals -4, zero product property, right? Now, graphical analysis for the graph of x squared minus x minus 20, these are the whats. Anyone know? Those are the whats. Yes. Intercepts, and actually the x-intercepts. So 5 would be an intercept, and -4 would be an intercept. Let's take it a step further. For the graph, which direction would the graph go? Up or down? Which way would this graph go if I were to graph it? Up. Do you have a question? Oh, okay. We're just doing verbal responses out loud. So, oh boy. Input, say it. So what I want is, and what you have to understand for this graph is, well, and this is easy. What does it mean if I inputted 0? Well, let's look up here. Let's input 0. What's 0 squared minus 0 minus 20? What do you get? What's 0 squared minus 0 minus 20? -20. Is -20 less than 0? True or false? True. You know what that makes 0? A solution. It makes it a solution. Does 1 look like a solution? I don't want to have to keep plugging this in, but what kind of output am I getting when I plug in 1? Negative. Are negatives less than 0? Yes. All of these x's give me negative outputs for y, which are less than 0. This is why this is the most powerful and easy thing in the world. All of these x's create negative outputs, which are less than 0. So they're all solutions. By the way, is 5 a solution? Yes or no? What happens when I plug in 5? What am I supposed to get on this side? Starts with the Z. 0. Is 0 less than or equal to 0? Yes or no? Yes. So guess what? These are filled in dots. And guess what filled in dots become when you write this in interval notation? Bruh. Brackets. Got it? And that's it. This is why graphical analysis is the most powerful tool in order to solve quadratic inequalities. Is that a bear shirt? Yes? Who's number 2? Can't think of who number 2 is. DJ? Oh, it's DJ Moore. All right, nice. I'll tell you what, if the Bears lose this weekend, I'm going to lose my mind after. You know what we got to do? Let's switch this. You know what I'm here? No, wrong. Let's change this. Ready? Are you ready for this? Boom. All right. So let's put that. This is what I told you about. You could always be dealing with. Well, no, I was telling it the first hour. I'm having a flashback. Sorry. All right. So the first thing you would do. So I didn't do anything. I just changed the question. So let's pretend this is the original question. I want you to know the power that you have in order to do what you want. By the way, this is something I haven't said. I don't think. Whatever you do to one side, do to the other. That's an equation inequality thing. So the first thing you would do is subtract 3 from both sides. So plus 3, so subtract 3. Again, those reds up there, I just changed the question because I wanted this to happen. Wait a minute. I tell you right now, I have the worst time factoring when the leading coefficient is negative. I can't do MA analysis. That's another brain gasket. It blows my brain gasket. Whatever I do to one side, say it. So guess what? I can multiply both sides by a negative. Unfortunately, when I do that, what happens to that inequality? We just said this. It flips. So I do want to rewrite this then. So this is 4x squared minus 8x plus 3 greater than 0. First of all, I would do this because I cannot factor with a negative leading coefficient. My brain can't handle it. All right, it can't. So when I multiply by a negative, this inequality flips, and that's got to be made sure to happen. All right. Now, I told you this is as bad as maybe the factoring gets on the AP exam. The numbers are small. This makes me sad how many people can't figure this out. But I'm not saying you, I'm saying my students of the past, I hope it's not you. What multiplies to be 3 What are my only two possibilities in that blank? 1 and 3, or both of them have to be what? Which they are. Negative. So I know it's going to be -1, -3 here for factoring. So I know that's going to be the case. Now I just have to figure out 4x squared. What are my possibilities for 4x squared? 2x and 2x, or what's the other one, honestly? 4x and 1x. And if I did put 4x here and 1x here, they differ by 1, or it'd be negative, or 4x here, that'd be -12. That's too large. So what I'm saying is I know it's 2x and 2x. You really don't have hard things to figure out how this factors. And I always double check. 2x times 2x is 4x squared first. Then this is -6x and -2x. That's what makes me sad. Students that can't do what I'm doing right now. Making sure I get the middle term by just checking the outer and the inner in FOIL before I continue. Then, of course, -1 times -3, of course, is 3. Oh, all right. And then what we want to do is get those zeros. Add 1, divide by 2. I told you, we got to be quick on this. Add 3, divide by 2. And then we're going to do graphical analysis. What is 1/2 and 3/2? The x-intercepts. You know what? I'm going to make this really large here. So if this is 1, here's a half. And then if this is 1, this is about 2, so this is 3/2, right? 1.5, correct? Right, I'm writing it kind of small there, but I don't want it to be in the way. So these are really close to each other. That's why I really expanded my x-axis there. And again, I made the choice, and this can always be the choice. Which way is my parabola going? Which way is my parabola going? No, I'm on this one now with the greater than. So which way is my parabola going? That's tricky. So I saw people say down, but no, we made a change. And we're analyzing now the greater than 0. So that's with the 4x squared. So you can always make your parabola going up in this graphical analysis. I would always, because I cannot deal with a negative leading coefficient. All right. So I probably always multiply by a negative and flip the inequality just to, do that. So it is the greater than that we're dealing with. So it is up. Okay, input, output, which ones work? Does 1 work? Does this output work to solve this inequality? Yes or no? So you're saying, what kind of number is this for an output? Negatives are greater than 0? Is that true or false? False. So is 0 a good answer? I mean, that's way up there, right? Isn't that a positive? So isn't that good? So my answers that work are this: yoink and yoink. Those are the x's that create positive outputs because I'm now dealing with this equation here. A parabola facing up after I multiply by a negative, and now it's greater than 0. So how do I write this? It's very simple. The number way out here is -infinity, all the way up to 1/2. By the way, what should 1/2 have? A bracket or a parenthesis? A bracket or a parenthesis? Parenthesis. Why? What is 1/2? Starts with a z. It makes the 0, and 0 is not greater than 0. So 1/2 is not a solution. Union that with 3/2 to infinity. Got it? Got it? Got it? Okay. Oh. Nah. And nah. Does this look familiar? Look at your notes. The opposite of b plus or minus the square root. Okay, I'm not going to do the whole thing. B squared minus 4ac. We already did this one. We did this one, Mr. Samuelis. But all over 2a, it's an inequality now. So, tell me what was the answer in that radical form? Look at the example. What did we get when we simplified this? Good. Do we agree? Right? But wait a minute. This is not an equation. This is an inequality. These are real numbers. As a matter of fact, for purposes of time, I went to the calculator first hour and got them as decimals just to get people to understand that. I get my fat head out of the way. So -4 plus 3 root 2, press enter, that's just 0.24. That's between 0 and 1 on the coordinate plane, x-axis, and then -8.24. So I can do the same thing on this, heads in the way again. I can think about this graphically, that here's 1, so here's 0.24, 0.24, and then here is -8.24. It's the same thing. It's not a big deal, right? So I just, we already did this one in the video, and now I just turned it into an inequality, and I just have to do graphical analysis. And then yet again, which way does this parabola go, up or down? Every time you could almost make these go up. And then this is what the graph would look like. Vertex would be somewhere down there, and the graph would go out. Input, say it. What outputs do I want? Positives or negatives? Which outputs do I want? Positives or negatives? What kind of numbers are less than 0, everyone? Negatives. So yet again, all of these x's create these negative outputs. Those are the answers. So you could write this in one of two ways. By the way, bracket or parenthesis, bracket or parenthesis, bracket or parenthesis, parenthesis. So it's -8.24 to 0.24. Or you could get all fancy with it and put it in exact form and understand the -4 minus was the 8.24 negative. And then the -4 plus was the 0.24 approximated answer. This one is approximate. This one is exact. Okay, they're the same answer, just one is in exact form, one is in a decimal approximation. And you got to understand those differences as well. Okay, so again, that's not hard. This is, though, oh no. Does anything multiply to 5 and add to 2? Anything multiply to 5 and add to 2? The opposite of b plus or minus. And then what did we get? What did we get? What do we get? Good, they're still going. What do we get when we solve this one? Can you look at that one again? I thought you were the one. He's still. What do we get for this answer here? Remember when we did this one earlier with the opposite of b? Wasn't it 1 or -1? -1 what? Plus or minus, right? Wait a minute. Wait a minute. Okay, now we're reaching back, and I hope you did this in Math 2 regular. I know in Math 2 honors we did it, and I know Math 3 should be pros at this. The question is, if I get imaginary zeros, what does that mean about the x-intercepts of the graph? Are there any? No. Okay, so what does this graph look like then with imaginary zeros? Which direction does this go? So this is what the graph looks like. It's got to be somewhere up here going up, but never crossing the x-axis. That's what imaginary zeros mean. Math 2 regular, just lock it in right now. Okay, it should make sense because over here we got real zeros, and sure, they're the x-intercepts, they cross, so the graph's got to look like this, crossing the x-axis. When you get imaginary zeros, that's the definition of not having x-intercepts. That's why this is happening. So now I ask you, which inputs create outputs that are greater than 0? The answer is all of them. Every single x value creates a positive output value forever and ever. So the answer to this is all, anyone? Real numbers, but in interval notation, that's -infinity to infinity. Listen, what if I change this to less than 0? Then which inputs create outputs that are negative? None of them. So if this was the green inequality, then this would be no solution. And that you need to be aware of those two unique special possibilities. Is everyone okay? All right. So that's why graphical analysis is actually good. Now you can go ahead and do your homework. Guess what, though? I'm going to do one. So your homework is right here, but I printed this one today, didn't I? Didn't I? Okay, and I'm randomly gonna do number 9, just because it's a mess. And then you can go ahead and write this down. Nope, that didn't work. Let's see, there we go. And I did do this last hour as well, and I'm just gonna do it right now. I kind of thought about it at the end. What the heck? Okay. Just wanted to get this here. Okay, of course, you always clean up, everybody do their share. Anyone know who that is? No one knows who that is? Clean up, everybody do your share. Barney? You're gone. Okay, oh, all right. So this is minus 4x plus 4 less than or equal to 0. What multiply? So the only thing I wanted to cover was, okay, this is a mess. You got to distribute, clean up, get everything on one side, compared to 0. Say compared to 0 now. But then it ended up not being bad, because what multiplies to 4? What multiplies to 4 and then adds to negative 4? Those numbers exist. Negative 2. So this is x minus 2, x minus 2. Wait a minute. This is why I'm glad I accidentally did this. The reason I did this first hour is just because of the mess. Hey, you got to make sure you clean these up. Then actually something special occurred. You know what this means? The x-intercept is 1 x-intercept, and it's at 2. So what does that mean the graph does then? That's actually the vertex. And which way does this graph go? Yet again, that we can always do. Up. So I'm glad that happened, because this is yet another special case, just like that I number case, but a little different. How do I analyze this then? Well, what numbers are less than or equal to 0 on this input-output thing? There's only 1. What is the answer that solves this inequality? 2. Because this creates a positive. This creates a positive. This creates a positive. Positives are not less than or equal to 0. So randomly, this inequality did result in just one answer. You want to get nuts? Let's get nuts. What if I change this to greater than 0? Oh, that'd be all of them except 2. Sadly for that, how you'd have to write that is negative infinity to infinity, but not 2. You'd have to interrupt that. I hope I'm not blowing brain gaskets here. It's just graphical analysis, but then you really got to be keen on what's happening here. And then if I put greater than or equal to 0, then it's all real numbers, because equal to 0 and greater covers everything. So you got to be aware of these special conditions. Okay, all right, now I'm done. Oh, I don't even know how to get out of here again.